Welcome to our first online Flux School via Zoom meeting. My name is Stephanie Wegner. I work in the office for the Flux Association. We would have gladly carried out the Flux School personally with you at the members' location. Unfortunately, the ongoing pandemic does not allow this. We are all the more pleasant that we are holding the Flux School online for the first time today. I would like to briefly introduce our association to you. The Association of the Flux Industry Europe was founded in 1981 in Büdingen, Germany. As an association, it is our first priority to popularize the advantages of Flux technology and moreover, the developed flocking to make its application safer and more environmentally friendly. By this means, we do not only want to improve existing applications of Flux, but we also want to initiate new ones and hurry enlarge the market for all members. We are also actively involved in the development of safety technical regulations and quality standards. The association guarantees important information transfer between its members' companies, science, and politics. We understand ourselves as the representation of interests of all companies participating in flocking, having chosen to accept a membership of the association. Our members are interested parties, are supported in questions related to the Flux technique. This not only includes the flocking companies in many special areas, but also those peripheral industries, manufacturers of flocking machinery, Flux tow, the raw material of produced fibers, Flux adhesive, Flux fibers, substrate material, pre- and after treatment methods, dealers and representative from the Flux trade, engineering offices and consultants, activity scientists and institutions. Also users and finishing company of Flux material are approached. The Flux industry consists of a widespread trade structure. Members are not only large companies or their Flux divisions, but also handicraft and enterprises and small-scale companies, flockers, suppliers, consultants, and reach institutions. The organs of the Flux Association of Europe are the Members' Assembly, the Executive Council, and the Board. All proper members have one seat and one vote at the Members' Assembly. Executive Council and the Board represent a cross-section of the entire trade. Thus, a well-balanced representation while concerning the interest of all members is guaranteed. Good reasons for being a member at the Flux Association. Be one step ahead in the technical developments, quality standards, and news of the industry. Inquiries received by the association are forwarded to our members exclusively. Publishing of the company contacts and their activities in the register of the members and Flux news. Possibility of free reporting on news from your company via our newsletter. Regular association events for information exchange. Special conditions exclusively for members for participation in association events. Joint trade fair approaches with our members, maybe for example, at the Tech Textile in Frankfurt or the K in Düsseldorf. Take advantage of the basic and extensive knowledge. Meet international experts and use the network. Regional, national, and international meetings and workshops. I would like to inform you about an important event of the association next year. Our 26th International Flux Symposium will take place in Barcelona in March 2022. Future more information will be available on our website shortly. The Flux Symposium is for members and for non-members. We would be very happy to see you there. So now we want to start with the Flux School program. I head over to Klaus Schreiber from Velotex. He will give a lecture on the subject of Flux. I wish everybody a lot of fun and a great Flux School. Thank you.
I'm Klaus Schreiber from Velotex Flux. I'm working for Velotex since 2003, so I'm nearly 20 years in the Flux business. So today we are speaking about Flux, and Flux has different meanings. So we see what is the Flux definition. There are different meanings of Flux, such as tuft, or a waste of fabrics, or very small tufts, or fillings. But the most important is we are speaking today about Flux, which is a short textile fiber, which is prepared to be placed on any surface with any substrate on a basis, on an upright position. It's kept in a perpendicular direction and held with an adhesive. So we can Flux nearly any surface with any fiber. So the first thing is to do the surface, we have to put some adhesive. Depending on which surface it is, there are different kinds of adhesive, but this is the part of the next speaker. We have either full surface adhesive, or also partially adhesive. Then onto the adhesive in an electrostatical way, we would, or electronically or pneumatically, we deposit the Flux onto the surface. This is called the flucking. Afterwards, we have to dry and to also to clean the surface. Flux, first time it was spoken about, the Chinese had the first possibilities to put a resin glue onto as an adhesive for textiles, and they scattered it, they shook it as natural fibers. It was 1000 before Christ. The first wooden model started then in the year 1200, in the medium age, but the real flocking began in the 40s after the Second World War, where also Velotex started in the year 47 to produce a kind of Flux with the waste of they had two companies, a company producing then Flux and a company producing machines for cutting the wool of the sheep, and the waste which was then left, it was wool, short cut wool. They started to Flux to prepare this as a Flux. But the real start began in the 50s with different kind of flocking on paper, and also starting flocking with different materials. But the real success began in the 60s with starting with modern machines. Also the adhesive became different to be used on different kind of surfaces. Especially in the 60s, the car industry began with Flux. Also very interesting was at that time the carpet industry, also photography and printing. Today we have all kinds of different sorts of Flux. Either Flux made of cotton, made of viscose, polyamides, acrylics, polyester, biopolymers, many technical fibers, new fibers which are now, especially for the environment, biodegradable or whatsoever, what you need. The customers are requesting every day more different materials. Well, let's start with the cotton flock, which is used mainly in the blackouts. That means on the backside of the curtains. This cotton flock is molded because it's not a single fiber. It's like a pulp, and this can only be grinded in a big grinding machine. But you can produce fresh flock. You can take the flock from the plant, but you can also take the flock, the fibers from the shredded T-shirts. Should be 100% cotton, and then it's a regenerated, recycled fiber. And you can recycle also this cotton fiber. It's not a problem at all. Well, that's the thing which Velotec started when they were cutting the wool from the sheep. But today it's not so used, neither the wool nor the fiber for the silk. It exists. We have some special requests from customers, but as you can imagine, the silk is quite expensive. Then we come to artificial fibers. There are different kinds of artificial fibers. Let's start with the natural artificial fibers because it comes from a wood, a tree, a bamboo, or something like this. It's a natural source. It can be certified, and we have certified FSC flock. It can come in a molecular structure as a cellulose. It can be also biodegradable, which we have, and compostable. So there we have different kinds of types of viscose. Let's say the most common viscose is the ordinary rain viscose. But we also have a model, and for some very special applications, we have the lyocell fibers, which have a different, let's say, different characteristics than the normal viscose. So then afterwards, we have also the big field of the synthetic fibers, which originally come from the petroleum. So it's a kind of chemical synthesis, a polymerization, where you melt the small pellets, either polyester or polyamide. They got melted, and afterwards they are pressed, like we say in Sweden, like a Spätzlepresse, depending on the size of the holes of this, or let's say for the Italians, it's like a spaghetti press, no? Depending on the hole, you get a different latex, and that means a different thickness of the fiber. We have, in this case, we have, as I told you, we have the polyamide, the polyester. The polyamide we have at the moment, we have biodegradable polyamide. Then we have some special fibers as aramides, carbon, glass fibers, and so on. So I was just talking about the thickness. We have different kinds of thicknesses of the fibers, depending on the requirement of the customer. Well, normally we start with a very thin DTEX. It's 0.9 DTEX, which means about 10 μ. And it goes up to 100 DTEX, which is about 120 μ. The thickness, depending always on the, as I told, the requirement of the customers. The range of the flock is extends. We are adapted to produce any type of final product and performance. Also, the flock types can be produced in various colors and also in different kind of, how you call it, in different kind of preparations. If you need a hydrophobic, which means not, or hydrophilic, which water liking or water disliking flock, this depends very much on the customer's end use. Our range of flock starts, as I said, from 0.9 DTEX. In polyamide goes up to 100 DTEX. There we have also some biodegradable or recyclable flocks, or some functional flocks such as flame retardant or bacteriostatic, UV resistance, which you need for outdoor application or sometimes also in the car industry. Then we have polyester, which is mainly used in the car industry. Viscose, we have a range from 0.95, either the molded one or a flock which is where the fiber is 0.95, up to 20 DTEX. Well, in cotton, we have different types of grade of the of the length of the fiber, depending how the knives are positioned in the molding machine. Then we have also some other fibers as acrylic, aramid fibers, and so on. All the different fibers have, of course, different characteristics, also depending on the application which the customer might need. As you can see, for example, isolation, wool is the best of the isolation, but wool is not very good in abrasion resistance or shrinkage. On the other side, the flock which we'll use most is the polyamide. The isolation is quite good. The abrasion resistance, especially in the car industry, I will come there on later, it's very high. Shrinkage is also very good, and the tenacity is good. Well, I don't want to now to see every case, but the most important is no, I wanted to see also polyester. Polyester is used is also in the car industry, but more in the window panels. As you can see, the isolation properties is not so good. The abrasion resistance is quite good, but it doesn't absorb any water, and this is the advantage in the window channels. For example, if you got the polyester and you in winter or when it's raining, the polyester doesn't take the water, which is very good. So we have different kind of flock types, and the characteristics they define themselves as either we have a circular, which is a round fiber. We have some special triller fibers. They look like a bit like a star. They take much more material. For example, these triller fibers, they are used for the paint rollers or for they are also used in the cosmetic to take more material for the application of eyelashes or whatsoever. Then we have different kinds of brightness. Some people, they prefer a dull flock, others they prefer a bright flock, but this depends very much on the titanium dioxide which is in the fiber. The more titanium dioxide there is in the fiber, the more matte the flock is. Well, the diameter I showed you before, we have between 0.3 up to 100 DTEX. And the length, this also depends very much, the length, but this I will show you later, the length and the correlation to the thickness, it's very important. We have lengths, for example, we have the smallest flock we have is 0.3 DTEX and 0.3 millimeters. So, the flock geometry is one of the most important things in application of flock. There is always a ratio between the thickness and the length of the flock. And this ratio gives you some possibilities to play. But outside this ratio, there's no possibility neither for us to produce nor for you to flock. For example, taking a flock which is very much used in the automotive sector, especially in the ceilings for the windows, it's a 3.3 DTEX in 0.5 millimeters. which gives you in a calculation a 6.6 ratio. That means 6.6 is very high. It's easy to handle the flock. For us, it's easy to produce. We can produce high quantity. And for the people who apply the flock, it's also very easy to apply it. On the other side, we have a lower ratio, for example, with a very thin flock, which 1.7 detects in 0.7 millimeters. This gives you a lower ratio of 2.4, which makes the flock soft, but also more difficult to apply. If you now go down, for example, to a 1.7 detects to 1.2 millimeters, it's a flock which we are producing, but it's not easy to produce. And for the customer, it's not easy to apply because the ratio is very low. So somewhere there's a limitation. For example, if I take a 1.7, 1.2, this is really the limit we have. So in between these ratios, we have to work. We have many customers, they're asking, for example, for a very long flock, but very thin. And then we have to say, sorry, this is not producible. For us, it's difficult because if the fiber is too long and too thin, then we have problems in the production. It will produce balls, and the same problem will have the customer as well. So very important also for the flock is, of course, the conductivity, because without conductivity, you can take like salt and put it over the material, and it doesn't work. You have, to get an upright position of the flock, you have to have a flock conductivity. And this conductivity you can measure, for example, with a kind of machine. It tells you which malo it has, which conductivity under certain constant circumstances it has. For example, we recommend to our customer to use a malo, which is the conductivity value between 80 and 100. It depends, of course, to the flock type, but let's say that's the normal range. The humidity of the area around the place where the flocking section is very important, because the flock is, let's say, it's taking, if there is too high humidity around the flock will take water, which then means, related to the conductivity, the malo is increasing, and the other way around. For example, in winter, if the place where the flocking section is not climatized, in winter you have low humidity outside, so the flock will get dry and will be difficult to flock, or it even can be dead afterwards. So we recommend to our customers to climatize or to air condition the section where the flocking part is, where the flocking machine is, to at least 50 to 60% humidity and a temperature between 80 and 23. Under these circumstances, the flock normally should run very well. We also recommend flock to leave at least 1 day in the flocking sector under these conditions, so he can acclimatize itself. So we have different characteristics of the flock. Of course, the haptic is very nice. If you touch it, it's like velvet. It's sealing possibilities you have. Also, you have sliding and gliding properties, especially actually as many of the car trunks are electronically. You have flocked springs inside, which also reduces the noise, and on the other side also makes the sliding very easy. Vibration is going down if you use flock, while you have isolation in many cases. Well, the application sector is really big. let's now come to the how we produce the flock. The flock normally doesn't come like this. You have a normal fiber, let's say a polyamide tow or a viscose tow, which we have to cut. The tow is depending on the applications, varying, has different thicknesses, the tow, and we have to adjust the cutting machines to the length which we need. So we have a precision cutting with about 12 or 15 machines. So we can easily cut many tons per day. After the cutting, the flock goes into big bags, and from the big bags it goes into the preparation and dyeing system. These are big machines with about 5,000–6,000 liters of water inside. Also we add then, of course, the chemical material. There's the dyeing. You put not only the chemical activation material, but also if you need colored flock, you put also the coloring inside, which is also totally automatic. Every machine in Velutex has its own computer system to, so it's the person responsible for the machines, he at any moment he can say where is actually the flock, at which state the flock is. After the activation is and the finishing, we have the spinning area. It's like if you have a spinning at home in the washing machine. After washing, you get the water out of the machine and of the, not of the machine, of the clothes. So we have to get out the water of the flock. After that, we have to dry the flock, and also after the drying, the flock is going to be sieved. That means all the long fibers, which should not be inside, but which can happen, are eliminated. And then we are taking also, during the process of dyeing, we take out some samples to see whether the malo and the conductivity, everything is okay. Then it gets packed, and before packing, we take, of course, a laboratory sample for our records for the future, if there would be any questions. Well, the tow, as I told you before, it comes in card boxes, endless packed, you know, it's starting in the bottom and going up like this. And as the machine cannot cut just a small tow, we have to combine many tows and to put them together into the mouth of the machine where it's cutting, you know. And we have also the knives are sharpened in time, and the people are looking that everything is okay in the machinery. Of course, we get mainly orders from customers. They have their own colors, they have their own requests. So in the laboratory, before doing the whole production process, we make small samples in a 10-liter box, and there you can make not only the colors, but also the finish of the flock. And then it will be transferred to the actually production, whether the customer needs 100, 200, 300 or whatever kilos afterwards. And, well, it's also very important. We have many spun-dyed fibers, especially used in the car industry. Spun-dyed fibers means that the pellets are already black, white, black or colors, and the yarn coming outside or the tow coming outside has the color which originally is then needed by the end customer. So we have just to we have not to make any coloring. We have just to prepare the flock and give a preparation on it. The advantage of these spun-dyed fibers is the high resistance to UV light. You know, it doesn't change the color because the color is in the fiber, and when you dye a fiber by yourself, a fiber which is normally off-white or raw white, then you're dyeing also only the outside of the fiber. Well, it's another important thing, especially in the last years. The people are looking for protective agents such as anti-static, antibacterial, or or protective against fire or whatsoever. And of course, this we are developing in the laboratory. This is another picture of one of the machines where the Flux is produced. This is another. This is one of the pictures of the dryers where the Flux comes in after it has been taken away the water. It's going to be dried. You can test exactly in the machine the conductivity and the malo value, and afterwards it's automatically sieved to get out the long fibers or whatsoever, and then afterwards it goes directly into the card boxes. So it's an inline control during the production and an end control after production. So there's always the Flux is always under 100% control. Well, normally at this time I should put a film, a short film, to see the factory of Velutex. Okay, thank you very much, Michael. This was the presentation of Velutex. Velutex will have their 75th anniversary next year during the period when we have the Flux Symposium in Barcelona. So perfect. We will have a big party next year. But coming back to the Flux, well, the Flux has different applications, as I told you before. This my colleague put in here. Well, it's a picture of Dior where all the puppies are flocked and the backsides are flocked. Everything is flocked here. Yeah, well, a very creative, decorative. Well, we have come customers. They are flocking candelabras and they are flocking windows and so on. The range is very big. Well, but as told many times before, Flux application is very important in automotive sector, especially for glove boxes and other boxes inside the car, or for noise reductions. We have customers that are doing also belts for the engine, or now the springs for the hood of the cars, which many cars have electronic hoods, and also very important still in the automotive, is the flock for the window seals and the rubbers in the windows, but also actually technical fibers are important, paper flockings for packaging or also for other things. Cosmetic industry is very important in different cases. Well, actually cosmetic is running quite well after the very heavy bad year last year due to the COVID situation, when the ladies, of course, when they are staying at home, they didn't put any makeup or didn't take any cosmetics. And now at the moment, I think everything is, thanks God, it's starting again. Well, we are with our flock, we are delivering any sectors also for the industry of the kids or for electric trains with long fibers to create landscapes whatsoever. Well, we have some examples for the applications, for example, paper, for wallpaper. It's a pity, wallpaper had been a very big market, especially the English, they liked it, and the Swedish, they liked it very much, flocked wallpaper. But of course, you can't flock a whole side of a wall, but special applications, let's say 1 or 2 meters of one side, and it looked very good, but it's not fashion anymore. Maybe it comes again. Cards, well, birthday cards, whatsoever cards. Packaging, well, packaging, it's more or less, it's for luxury packaging. Even I saw Lindt chocolates, and then the card box was flocked whatsoever, or perfume, you know, for very high-class perfume, the outside boxes. We have customers like Paco Rabanne, they flocked the outside box. Well, if it's necessary, I don't know, because afterwards the box is in the litter, and for me it's wasted, but well, for us it's okay, and for our customers. Landscapes, as I told you, for the electric trains, different kind of landscapes, either for winter, summer, spring, there are different colors. Maybe most of the time it's a mixture of fibers, mostly in viscose and 2-3 millimeters long. Industry and building, as I told before, paint rollers. The small paint rollers, they are flocked with driller bar flock, and the driller bar, as it has a form like a star, it takes a lot of material, and it's easy to paint afterwards. And the big sector of automotive with rubber profiles, glove boxes, and so on. And there you have normally not a big range of flock. Most of it's a polyamide or polyester 3.3 D-Tex. Sometimes we have a 1.7, and in special cases, we had also a thicker flock. And then we have also, of course, the carpets, which we always have from Forbo flocking in the UK, when we have our stands on the K or on the Tech Textile. They send us their flocked carpets. Very resistant, easy to clean, and well. Cosmetic, I also talked about the cosmetics before. There we have different ranges. We have especially the flock for the foam to applicate the color on for the ladies. The cosmetics. Then we have the pencils for the eyelashes or for the lip gloss whatsoever. Also lots of decoration. We are sending much flock to France, for example, for the Christmas tree flocking. For them, it's important to have a Christmas tree, which is flocked with white cotton flock. Well, here in Germany, it's not so used, but sometimes it's seen. And so we now come to the last sector, which is still, it had been very important in the 90s and in the 80s, textiles. It's, well, if you can remember, most of the T-shirts from the big football clubs, they have been not printed, but they have been flocked with a logo. And for me, it was perfect because it was 3-dimensional, and it looked nice. But today they are not flocking anymore. They are just printing or serigraphy or whatsoever. but still the textile industry is running quite well. And we have lots of customers that are using different kinds of flux, especially in the high price level, for the lady wear, underwear, for swimwear or whatsoever. So I come to my end and I thank you very much for your attendance. It was a pleasure to have you here, and I wish you a very good day together with us and lots of experiences.
Thank you, dear Klaus, for your presentation. Now we have some questions. The first question is, what is the FACRA level who Velotex offers for black dyed flock?
Can I answer? It's a very good question. My problem is I'm a salesman, I'm not a technician. But on the gray scale, I would say our flock is between 4.5 to 4.75. But for the spun dyed flock, black.
So as Stephanie already said, I will take over the part of the adhesive. So yeah, short words to myself. I'm Tomasz Jasecki and responsible with our team for the flocking adhesives worldwide, which means we are selling from Wiesloch all over the world. And I would just start with a short video and to give you a short insights. Start now.
Noch nicht.
Kissel and Wolf was founded in 1893 in Wiesloch near Heidelberg. Nearly 100 employees helped the company play a leading role in a number of areas, including screen and textile printing, as well as manufacturing adhesives, resists and coatings, and cleaning chemistry. Apart from in Germany, the company has operational centers in the USA, Singapore, Australia, Brazil, Turkey, and India. Our research and development department, which represents around 15% of employees, ensures that we maintain excellent levels of innovation. In addition to continuously improving our existing products, we also challenge ourselves to develop new innovative products to drive evolving marketplace trends. The R&D team enable us to remain ahead of the game and to retain our global competitiveness. Our extensive storage capacities, together with our sophisticated warehousing processes, ensure excellent raw materials availability. This supports our pre-production planning, as well as assuring consistent product stock levels, which gives our customers peace of mind for excellent product delivery through on-time shipping. We attach great importance to our reliable production quality. Over 95% of our production is in-house, where our technical know-how and good manufacturing practice fuse together with high-quality raw materials. Modern production facilities ensure the excellent and consistent high quality of our products. Our application department is a key interface between us and our customers. We work closely with our customers to test new or enhanced products in their manufacturing conditions before they are released for sale. We use state-of-the-art machines and technologies, such as our scanning electron microscope. This helps us optimize, for example, the use of screen printing in the electronic and solar panel industries. This means we can test our products in-house under realistic conditions, and therefore be confident that we'll provide the products our customers need. Every day, we discover more and more new applications and in new sectors for our products. For example, our products enable glass panels to be sandblasted or metal surfaces for car interiors to be brush finished. Our flock adhesives form the base for applying flock fibers to a very wide range of substrate materials. Surfaces then take on a velvety or brush-like look and feel. Other examples where our products are used include the textile sector, as well as the electronics and automotive sectors. Our products are also to be found in the decorative finishing of architectural glass and much, much more. Driven by our experienced management team and our motivated and professionally qualified employees, we are very confident of a successful future. We will continue to focus on and evolve our core competencies to ensure we'll remain leaders in the global market as producers of high-quality chemical products and in more and more new sectors. Please contact us for more information.
All right. Thank you very much for the attention. You've seen we are located worldwide. For the flocking adhesives, it's important to know that all of the products for the flocking adhesives are produced in Germany. And we do have a production in Houston, Texas, but this is for screen printing chemicals. So the flocking adhesives are produced just in Germany and sent out worldwide. We are producing under ISO 9001 and 16949 IATF, so with very high quality standards. Within this 4 business fields, you have seen it: adhesives, chemical products for screen making, resistant coatings, and cleaning chemicals. As I will go on with Flock, we still have seen a lot from Klaus, and I just want to make sure that everybody who has questions can ask their questions. Unfortunately, with my view, I do not see when someone writes into the chat. So if you have questions, please write in the chat, and later on we will take care of the questions. So I will go on with the presentation. Flock, okay, what is it? A lot of you know it already. A lot of you have relationship to it. So mostly we need 4 components, which is the substrate, the adhesive, which is our part, which is the, as it says, the bonding component between it, the fiber, and the flocking machine. There are a lot of different things that need to be taken care of while application. You will see it later on, but just for the first step, can I have here no, I think you see my mouse. So this is very important. This is the adhesive layer, this is the flock and the substrate. So I can confirm what Klaus said, that nearly any substrate can be flocked if, now there's the if, the surface tension is the correct one, which is like around 38 dyne. This can be achieved while a pre-treatment of the surface, which is necessary, example, for polypropylene parts. We will see on that later. We already have the knowledge now about the flock, so a lot of different types of flock can be used. And we have our adhesive layer, which should be roughly, or the flock fiber should be inserted into the adhesive layer around 1/10 of the fiber length, dried. Which type of adhesives are available? This is not only for us, this is also for others. So this is like a general information. We have water-based systems, or there are water-based systems, solvent-based systems, which can be either 1 or 2 components each, acrylic or polyurethane dispersions or polymers. But for solvent, mostly you need 2 components. For water-based, more often can be used as a 1-component system. In some cases, you need auxiliaries, as mentioned before, for example, a primer or conductivity agents if the substrate needs it, cleaning agents, or for example, a color if the adhesive doesn't have the color. Here I see the chat. I'm not sure if it will be possible. Yeah, so we will go on the questions, I think, later on. So I will continue with the presentation. If it's okay, Patrick, I'm sorry. So we'll do it at the end. Right. What water-based adhesives has some advantages. So for example, we can use it as a 1 or 2 component system. The mostly used parts for acrylic dispersions are plastic, metal, or wood. Sure, we have a few advantages for water-based and solvent adhesives. Sure, for water-based adhesives, you have less hazardous labeling. You can dilute it with water. You can also clean it with water when it's still wet. But still, it has very high and very good abrasion resistance and can be used one component. Right. For the polyurethane dispersion, mostly used for rubber profiles, EPDMs or PVC. This is mostly used in that area, same advantages. For the solvent-based adhesives, it's just polyurethane polymers, which is used for plastic, metal, rubber, or also for cosmetic applicators, which we have seen from Klaus before. We do have also a very high temperature drying. You can use it here, higher drying temperature. For water-based, it's not that high. You will see it later on. It is, the reason is that a water-based system boils, with 100 degrees, so we cannot dry it over 100 degrees. So for solvent-based, this is possible. It does have a longer open time. So the open time is the time when the adhesive is applied on the substrate, how long you have time to apply the Flux fibers. It's mostly two-component system and high water resistance after drying, and high cosmetic and perfume oil resistance as well. Yeah, we have talked already about the cleaning agents. So I just want to say about a few things about the performance. Sure, a lot of them are known, like the abrasion resistance, which is a very important one, noise, vibration reduction, the chemical resistance, for example, for perfume oils, heat absorption, seal tolerance, example for the rubber profiles in the window profiles, and surely a haptical or optical performance, for example, for textiles or for designs. So a lot of things are possible here. In this, focusing on the flocking adhesives in action, and for example, in the automotive industry, we have heard already a few, like the glove box, which is mostly ABS or ABS PC, or like I said here, also a PP part when the pre-treatment should be over 38.9. For example, trunk lids, door profiles, or seat adjustments. Yeah, we also do have way more, like paper. We have some toys, cosmetics, decoration, glass. We also have like porcelain adhesive, which is for dishwasher resistance also. For everybody knows it, for sport or design purposes. Sure, also for example, we do have different applications, which I will also continue later on. Mostly used is spraying, screen printing, also rotary systems. But again, mostly it's used for spraying application, or dipping, like the cosmetic tips, or everybody unfortunately was in contact with the COVID testing. This was also dipped. It's mostly dipped. All right. This was the first part regarding some examples, the first informations. But now I will directly go on the key requirements of adhesive. So when there is the chance, or when there is a possibility to have a substrate from the customer or from a project, then we normally identify the best adhesive, and then there are a few requirements for the flocking which need to be adhered. So you really need to stick to those informations and requirements to have the best possible performance. surely this what I say is also theoretically, every project, every flocking, every situation is different. So surely there are can be variances in it, but what I will show you now is the theoretical standard information. So it is very important to have a proper mixing ratio. For example, for solvent-based, it's mostly 100% or 100 components to 100 components, or for water-based systems, mostly a 5 to 10%. So you really need to stick to that, not thinking, oh, if I put more hardener in it, it will get better. No, it doesn't. So you really need to stick to it and need to have a homogeneous mixing, which is which is important. Also, the steering is important, that it's not too much speed in it, to put too much air inside of the adhesive system. You don't need to mix it all the time. It depends on the system, but it's enough to steer it once a shift with medium speed. So I again come to the open time and pot life, which are two major things. So the open time is again the time when the adhesive is applied, for example, for spraying, how much time you have till the flock fiber is applied with the machine. And for water-based, we have 3 to 4 minutes roughly, depending on the humidity. And for solvent, we have around 30 minutes, depending on the temperature and humidity as well. So this means, for example, just to get an idea, for solvent-based adhesive, why it's that longer. The reason is that we have solvents in it, right? And the solvents dry from the bottom. So when we have the adhesive layer, it starts drying from the bottom, because the upper layer can't dry because the solvents dilute this again. For water-based, the water the water-based system starts to dry from the top. So after 3 or 4 minutes, the dried adhesive layer have like a skin, and after that 3 or 4 minutes, the flock fiber can't go inside of the adhesive layer. So that's why we need to be very fast in that case. For pot life, it's also different between water and solvent-based. For water-based, you have like 4 hours time. So when the adhesive is mixed, if it's not one component. For solvent-based, it's also a bit longer. Sorry, it just takes some time to go on now. Yeah, so the same situation for flock is also for the adhesive. So there are requirements should adhere at best, which is the temperature while application of the adhesive should be around room temperature, and also the storing temperature should be around 5 to 25 degrees within the standard packaging. It's roughly like 1 year shelf life. The humidity should be around, so in the application area, around 50% relative. By temperature, it's best also when you start working, or for the next day, you prepare the work for next day, when you have a storing temperature of, let's say, 10 degrees or something, and your room where the application, if the adhesive is 20 degrees, it's best to store the quantity you need for the next day within that area already, to warm up or to get the adhesive prepared for the next day. Drying is possible in a few ways at room temperature. If there is no proper heat necessary, mostly by, let's say, 90–95% of drying is possible by room temperature. It just takes longer to get the final curing, the final result. So normally we have a final cured adhesive system after 72 hours, but you can process it already with 24 hours. If you use it in the oven, for example, water-based, 20–30 minutes with 60 or 80 degrees, you can work with it already. And for solvent, also 30–40 minutes and up to 100 degrees. Again, this is standard values. It can be faster, it can be longer. It just depends on your oven. It depends on the airflow of the oven. It depends on the humidity and so on. So there are a few requirements also which can change this. After the oven drying, you still need around 48 hours till the final curing is achieved. This is very, very important because if some customers did a test, for example, and then did the abrasion resistance test directly after it comes out of the oven, it doesn't work. It works, but it does not have that good or that final result. So we need to wait then 48 hours at least. And every time be careful with too high temperatures. Before we heard that we need to have 1/10 adhesive layer dried, where the flock fiber should stick in, right? So we have here, our product data shows around 45 to 60% solid content, which means this is the quantity which stays on the substrate after drying, roughly. So for example, when we have a 1 millimeter fiber length, we need roughly 100 microns dried adhesive. With a solid content of 50%, roughly, we need to add 200 microns of adhesive layer, wet. Then it dries, and we have afterwards the 50% solid content on the surface, which adheres the flock fiber. We have viscosities around 600 to 5,000 MPa, depends on the application form. Yes, and the conductivity of the adhesive should be minimum the same or better than the flock, so that the conductivity is given, right? This is very, very important. Cleaning, easy said before. For water-based, you can use water. When it's dried, of course, you need chemicals. Same for solvent-based. When it's dried, you need the chemicals, but also already when it's wet. We know that for coloring, it's the best, or from values and abrasion resistance, it's the best and very important when the adhesive is the same color as the fiber, which means when we have a black color fiber for the automotive industry, we should also have a black or grayish color of the adhesive, which shows better results. It's also sure when you have a black adhesive and a black substrate, it's maybe hard to see if you have the best and proper application, or you can't see the best on the substrate if you have a good adhesive layer. So in that case, when you use, for example, a grayish adhesive, you see a difference between the adhesive and the substrate, so you can optimize your spraying. We achieve, just as an example, with our adhesives, we achieve a lot of abrasion resistance and quality requirements from the customers, or from the OEMs. There are a lot more. Just show you a few. And in case you hear from the adhesive point of view the word adhesion or cohesion, just go on with that. So for example, the adhesion is the adherence from adhesive to the substrate, and the cohesion is the inner strength of the adhesive. So for example, when there is when we do some tests and make, for example, a rip-off test, and then you rip off the flocked system, so flock fiber and adhesive, from the substrate. And this needs to be really carefully looked at on a microscope, because in that case you have two options. Either you see that the adhesive breaks, or the adhesive rips off the surface from the substrate, and this is mostly the case. So when there's the testing finally done and you rip it off, you test it with the microscope, and then you see, okay, the adhesion between the substrate and adhesive was so good that the adhesion layer ripped off the surface. So this is the best result you can have, and the best adhesion you can have. And this is the case in this test, for example. I go on with the application methods you have seen mostly used is spraying, like you see it here, but also screen printing, rotary system, dipping, brushing, everything is possible. What is done by the customers mostly is again spraying. As mentioned before, the surface tension is very important. You can test the surface with a few different things. For example, mostly done is some ink, some testing ink, or like an ink pencil. And after primering, or for example, flaming, corona, plasma, grinding, so there are a lot of different things you can do. And you make the test again, and then you have a better surface tension. Just as you see here, this is a good surface tension, this is a bad surface tension. And this is really, really important to have a good surface tension. How you measure the adhesive thickness layer, this is done mostly with an adhesive layer, but you need, when you start right at the beginning, it's you test this most or very often, but in the end, then after you get some experience, you don't need to test it, you see it. So this is a thing you can do. And there are a few different application methods, like a handheld electrostatic pneumatic, which is mostly used in the automotive industry, or a 3D cabin, for example, for porcelain. All right, that's it already from my side. So I would like now to go on with the questions from, just let me go on the questions here. All right, the first question was, all right, the first question, how does the adhesive influence the hydrophilic property? Honestly, I need to look up the word hydrophilic, sorry for that. Okay. Yes, this depends on the substrate as well. So it depends on where the water comes from, but you can't say it's an influence also on adhesive, because the Flux also is taking water. So it's not only the adhesive is taking maybe a bit, but also the Flux fiber does take the water on it. How it influences the property of the surface or the substrate itself, surely it need to be tested before and look what's the case in here. But honestly, I would hand over this question. Steffi, can you turn on Jürgen Katzenberger's microphone? I think maybe he can also say something on that. Or can I do this also? Ton freigeben.
It takes some seconds.
Yeah.
Wait a moment.
Yeah.
Hello?
Yes, Jürgen, we hear you.
Yes, the adhesive has no influence of the water properties of the fiber. It's the same as a substrate. So it doesn't matter or if the water, if the fiber is hydrophilic or hydrophobic. It has no influence of the appearance of the fiber, at least.
Yes. Thank you, Jürgen. I will go on with the next question. I hope this question was is okay. If not, Patrick, you can write us an email and then we can discuss this later on. This will be no problem at all, if it's okay for you. Good. Go on with, but foam adhesive is also used. Yes, sorry, sure. Also foam adhesives are available, which are also does not affect the softness of the flock of the foam. This is also possible. Do you include biocides in the adhesive, and does that convey antibacterial properties of the final article? Very good question. But for antibacterial properties, we do not have any adhesive which allows us to reduce it, for example, or for the medical properties. We do not have that much, let's say, experience, respectively, not that much projects we worked on, but we can check this within a discussion or a new adhesive. If it includes biocides, this depends on the adhesive, but we do not put in biocides by recipe. So no.
Is my microphone still on?
Yeah.
You're not quite right, Thomas. We add biocides, but it's just for conservation of the adhesive itself. That's no attack to our adhesive from bacteria or something else during the wet conditions.
Okay.
But
Thank
the dried adhesive layer is not conservated.
Yes, that's the case, right? What is the normal adhesive film thickness? Yeah, again, we roughly say around 200 microns, so we can say roughly 200 grams per square meter wet. So what is the glass transition? What do you mean with glass transition temperature, honestly? I also need to look up this word. Glasübertragungstemperatur, Jürgen. Do you know something about this too?
Yes, you can say it's different from adhesive to adhesive. The glass transmission temperature is higher if you have a rigid substrate or a rigid adhesive, but by a soft adhesive, it's very high. It's high. We say if you have a rigid one, yes, it's about 0 or 10 degrees, and otherwise it's higher. But normally it's a physical value we don't measure.
How about UV cure? We would love to do this, but by now the issue is that after the part is flocked, there's not enough UV to get through the flocked surface to cure UV curing adhesives. So by now, unfortunately, there is no UV curing adhesive.
You need so much energy to get through the flock fibers that plastic substrates are melting.
No.
And even if you have a dark colored flux, it's nearly impossible to get any curing. It's just possible for glass when you can do the exposure from the backside.
Right, exactly. For flocked wallpaper, is it normally by screen printing? Yes, rotary screen printing. How resilient? My English normally very good, but yeah, how resilient is the adhesive film? This depends surely on the requirement of the customer. So we do have very high quality and high reliable adhesives. So where you have that much high abrasion resistance that it will not happen. That's normal situation. The adhesive layer will fall off. For example, there's a resistance test from the Volkswagen Group. If you translate it, it would see that you park your car into a saltwater sea for 48 hours. Then you drive out of the lake, and you take your car key and scrap over it, right? Will never happen, but we will achieve it, or we achieve it. So we do have very high resistance it. Where it gets scratched without breaking, cracking. If you mean where it normally breaks, where it gets scratched without. Maybe can you repeat the question again, or can you write it again to me? So, honestly, I do not understand it correct, this question here. At what temperature does it become brittle? Yeah. So you mean, so when the adhesive layer is dried, the heat resistance is also depends on the adhesive, on the flock, but normally the temperature which can be critical for adhesive is more critical for the flock, for the polyamide or the substrate, before the flocking adhesive will get brittle. So we do not have an exact temperature where it starts to brittle. And please, you can correct me if I'm wrong, but by now I do not have an exact factor where our adhesive starts to break after it's dried.
You can say you can't say it in general.
No.
It depends on the adhesive. It's different from adhesive to adhesive.
Sorry. All right. Are you using core shell technology in water-based adhesives? Honestly, I also cannot answer this question because I do not know what you mean with core shell. Maybe you can also write the question in a different way so we can answer it. Application areas, vacuum forming and plastics for packaging. Yes, and we do have adhesives which are for example for polystyrol flocking, which means you put on the adhesive from the polystyrol, and then you had a vacuum sucking which forms the substrate, and we do have very good yeah, now I understand what you mean. And in that case we have a very good resistance, so the adhesive starts to break in a very long way, in very long distance. Surely after maybe 10 or 20 centimeters, the adhesive is broken. But within the first centimeters, the adhesive doesn't break. And we do have special adhesives for such type of packagings. Does the quantity of water-based adhesive influence the open time? No. The open time is mostly the same, 3 or 4 minutes. So even if you add more water, it may causes a bit different, but it's just within seconds. So yeah. Can dry film be made conductive, and to what level? So if you mean if the adhesive layer is still conductive, it should be tested. So I cannot say if still. The question is also how much conductivity you need. Do you want to, let's say, use it as a transistor or as a layer which can transport energy or electricity or something like that. Conduct electricity charge, yeah. All right. No. So by now we have no tests done if there will be a conductivity level which is enough to transport this electricity. But we do have some, not flocking adhesives, but we do have other things that other chemicals which allow us to transport conduct electricity charge. So if you have if you have further questions onto this, we can discuss this separately. No worries about that.
Dear Thomas,
Yes.
we have to come to the end at the moment.
We are at
Please
the end.
bring the last question, and after all lectures, we have a question round again. Okay?
Okay. So I'm finished. I think we have done all the questions regarding the core shell technology. We can also discuss this later on. No worries about that. So I appreciate your question. Thank you very much, and have a nice day.
Dear Thomas, thank you very much for this great lecture. And now we have a break for 5 minutes. And after that, we have the lecture from Alberto Sadun with the lecture is machine.
Okay, hello to everybody. I'm very glad that we have this chance to share information on flocking technology with all of you. 36 participants is a very good result. Thank you for the organization. And I have to tell you that presenting the whole flock machine environment word in half an hour is not so easy, but we will try to introduce you again to flock technology. And I think you can say that repetita juvent. That means that you will hear maybe some information that you have already heard for many times, but this is a collection of information that will make you a clearer picture about flocking machine and flock technology. So, okay. We start saying that flock technology is used in many environments. So you can flock plastic, you can flock fabrics, you can flock floors, you can flock automotive car interiors. So the range of product that can be flocked is so wide. And for each kind of product, many times there are different technologies. And we will try to introduce you the main principles about flocking and the different technology that we have to use for obtaining a good quality flocking in the several sectors. So we start immediately with the process of a flock process. And okay, so this is how flock is done. So flock needs sometimes a pre-treating. There are materials where you cannot apply the adhesive that keeps the flock linked to the object or to the substrate without a pre-treating. And then we will go through what does it mean pre-treating. The glue application is a must. Without glue application, you cannot obtain flocking. So the fibers will not stick on the substrate. The flock itself, so we'll go through with several flocking techniques. The pre-cleaning is also a must. Normally, you overflock. is not 100% of case. There are cases in which you only flock few grams. I make an example, the blackout, for just give you an example. But the most of the time, you want a nice density of flock, and so you overflock, and you need to collect the flock by a pre-cleaning process. And then normally, the pre-cleaning flock that you collect, you can reuse it. Then drying, very important, is linked to the adhesive. Drying and adhesive are very linked. So you have to have drying process that is following the instruction of your adhesive supplier. And also drying technologies are not all the same in function of the substrate and in function of the adhesive. Then cooling, after drying, in some occasion you can cool, and this is good for, is helping the final cleaning. Very important, one of the most important processes on flocking. Final cleaning gives the flock product quality. We know that a big matter, issues of a flocking process is really final cleaning. When you give a product to a customer and the product leaves fibers out of the product, this is very bad. And this makes really hard time to the flock industry. Then finally, the post-treatment. In some case, you apply some treatment once already the surface is flocked. We will try to go through also this. So, flock treatment, pre-treatment, we speak about an optimal glue adhesion on surfaces for polypropylene, for example, for EPDM, and polypropylene films. In this case, you need a pre-treatment. And the pre-treatment can be in different nature. In the rubber, you use buffing, sanding, and plasma. In 3D plastic, we use primer by spraying, flaming, you will see in some videos, and plasma as well. And then there is also another technology, the fluorination, that gives very good results, but it can be done only in batch. Instead, plasma and flaming and primer can be all done in batch, but also can be done in a continuous process. Glue application. Okay, there are, as Thomas has talked to you about, there are several kind of adhesives, and then the adhesives are in function of a substrate that you want to use. So sometimes you use waterborne adhesive, sometimes you use solvent-borne adhesive, and sometimes you use PVC. And this kind of adhesive are interfering on the equipment. Once that you use solvent-borne, you need to have a certain protection for the safety, and that you don't need when you use a waterborne. And then here we are to the different adhesive application. You have several adhesive application depending on the substrate that you need to flock. So spraying, that you can use it in APDM rubber profiles and 3D plastic. Brushing, by brush, there are APDM rubber profiles line that in which you apply the adhesive by brush, special technology by brush, and also in 3D plastic, but it's really craft work. Then instead, for fabrics and film, you will use different technology that can be by roll or by blade. We will see it. For plastic, for example, for applicators, you can use deep coating. And this is another technology. Then there is tampo printing. In some plastic parts, you will use a tampo printing for allows you to put the adhesive in curvy, very curvy, but very precise in very curvy surfaces. We have seen it in the application in Playmobil for the horses. And finally, but least but not last, the screen printing can work for fabrics, Flux design, and for films. And then there is a lot of application by screen printing. So in order to have a little bit more inside things, we will have two examples. A blade application, and I will show you a video, hoping that is starting. Yes, it's starting. So you are looking at a video regarding a blade application. In this case, you apply the adhesive by a blade, a coating head, and this is used in the fabric application, and also film application. This technology is used for example, for producing the film for rubber profile application. Or you can use spraying application. So, sorry. Spray application can be applied on three-dimensional parts. So you apply the adhesive by hand or by robot, as you have seen, in a way that the surface is totally covered by the adhesive. Of course, this has some problems. This typology of technology. Why? Because once that you are applying by spray, sometimes you need to mask, and then the masking system is not very easy work. As Thomas has mentioned to you, the adhesive needs to be properly applied. And very important is the layer height. So a correct layer is giving good result, but the layer needs to be determined also in function of the fiber that you are using. Okay, you will listen to, we have listened to the fiber lessons. And so the longer is the fiber, the higher adhesive layer you need. An average for the most used fiber, that is 1 millimeter, can be, okay, 200 microns. But there are cases in which you need more, and like cases that maybe you need less. But the correct amount of glue is necessary for the good result of your flocking application. Now we arrive to the heart of the flocking technology, the flocking process. So there are several technologies of how to apply flock in a surface. There is the pure electrostatic. That means that, and you will see the sample, the video about that. And then there is a pneumatic. The pure electrostatics is very good for your flat surface. And the result is the best. The velvet surface is very good. But once that you have a curvy and a deep surface, the pure electrostatic is not working anymore. So you need to change the technology of applying the flock. going through a pneumatic, electropneumatic system that has electrostatic, but also some air in order that the fibers goes deep into the object. Then you can have also a combination of electrostatic and electropneumatic, and some of the flockers are using this solution for obtaining the best results. And then the last is scattering. Scattering is the start of flocking. It's a so-called flocking. Many years ago, the first test of the first production of flock was without electrostatic. The electrostatic arrived in the 1950 around. So before, they were applying flock using only scattering system, but of course the results were not as good as the electrostatic system. So the electrostatic system, you now have in front of you, what does it mean? So you need it has to be as short as possible, so you don't disperse the electrostatic strength. It has to be possible as far as in the neighborhood of a line, and possibly has to be perpendicularly to the surface to obtain the best results. So these give you only a draft concept of what does it mean electrostatic field. So the fibers are pre-polarized. So you have two poles, and in the middle you have a flock electrostatic field that can reach in an average of 30-70 kilovolt. Then of course you have to speak about a lot of thousands of volts. So we have to pay attention how to treat the safety of a machine. And this is nowadays a very important point. So the fibers are going up, and this is the result. So you have the fibers are going from out of a machine, and they have to hit perpendicularly the substrate, like in this picture. So the result should be to have vertical piles on your substrate. So it means that you can obtain a proper velvet effect. Without the fiber being as more vertical as possible, you cannot have your velvet effect. And the electrostatic part is very important. So you can see from here how it appears in electrostatic field. So with the fibers, create clouds. So there is an up and down movement of the fibers. And then when they hit the adhesive, they have to stick. And the strength of electrostatic field helps to stick it properly. So what about the technologies for flocking different kind of objects? Or I have told you that with this linear and the fabric or films, you can use a pure electrostatic machine. But once that you need to flock a deep part, you need to use a help of air. So you have a combination of electrostatic field with the inlet of an air source. In this way, fibers can go all around your surface. So now we see a little bit about this technology on a video, but it will be more clear. So now we start with the 3D objects. So you have normally a chain that is transporting the objects through the different phase of a flocking process. Then you start with the flaming or with the plasma. In this case, you have a plasma is not possible to apply, so it's a flame, as you see. So the flame in this case works at a pre-treatment. So the pre-treatment helps the adhesion of your adhesive and avoids delamination. There are different systems. There are carousel systems that in which you apply the different process in a batch system. So the robot in this case is applying the plasma, and in this case the adhesive by spraying in a batch system. So it means that you have a man that is an operator that is placing the parts, or as you are seeing in this moment, you have application in a chain. So this means that you have no touch of the parts in the several application, but of course, once that you have a part that are needed to be masked, the chain system is not so indicated. Why? Because some small masks can be applied, but you cannot make complicated masks for parts that need to be flocked in a chain. So it's very various. There are several aspects to be taken in consideration when you choose. Then while we here in front of a pre-cleaning. The pre-cleaning, I will explain you, is a very important part of a flock process. The pre-cleaning helps you to have. Sorry, I go back in order that to have the part at the best clean before the oven part when you are drying the adhesive. So the pre-cleaning helps to save fiber that you are going to reuse and is a way for less pollution of an oven after the flocking application. So here we have ovens, and the ovens also is a very important part of a flocking process. The ovens can be in different shape, can be or in batch shape like this. You put the parts and then the parts are already flocked and pre-cleaned, or you have an oven in a chain that the chain pass through the flaming if it's needed pre-treatment, adhesive application, flocking, and then oven, and then final cleaning. The final cleaning that we are checking in this moment. So I hope that in a video way, you can realize better what does it mean then, okay, this is another matter. The flocking can be also for rubber profile. In this way, you have different systems. There are batch systems when the rubber profiles are applied in a second stage of extrusion, and this is the case. And then you have the extrusion part, where the rubber profile is flocking continuous. In this regard, we have to say that the flocking for rubber profile is really now going to be substituted by by the flock tape that is more practical. Sometimes can be applied and is very practical, but in some parts, in some profiles, the flock tape cannot be applied. This is an example of an extrusion line. Sorry. This is an example of a line for extrusion. So the profile go through as I told you, through a pre-treatment by plasma, adhesive by pincel, by brush, or by spray, then a flocking line like this that has hoppers and pre-cleaning, and then long ovens. So another part of a flocking can be also this kind of application. Also spraying adhesive. In this case, the adhesive is not only spraying, but also electrostatic spraying. So for some material, the electrostatic spraying adhesive is very interesting. Because yes,
Alberto, I'm sorry, nobody can watch the video.
Oh, I'm sorry.
Maybe they need another link, or maybe you can bring the video in the presentation.
Oh, but I think that I'm sorry. I thought because I have the video link in the presentation. So in my video was that the screen was shared with you.
Yes,
it's good that you told me.
For the participants, the video is not working. The link is not working. I don't know why.
Okay, so we will proceed with the slides. No problem.
Okay.
Oh, it's good that you told me.
You're welcome.
So practically, once that we speak about the flocking technology, and a very big aspect of a flocking technology, for example, is the environment where you flock, because the flock fibers and the flock electrostatic field is very sensible to humidity and to temperature, but more or less humidity. So once that you flock, you need that you have control the humidity rate and the temperature. And this is very good, big aspect, very important aspect. And some flockers are not really following it. But gives you the reliability of your process once that you have environment flock house. So in case of problems and defect, you are sure that the environment in which you are flocking is correct. So going to again the adhesive application. The adhesive application, as we said, is very important and has to be combined with a very good electrostatic application. So once that you see a deep intrusion of a flock of a fiber in the adhesive, you are okay. Your pile will not get out. But if you have a pure electrostatic, the fibers will be not penetrating into the layer of adhesive, and so easily will go out. So once that and then you have a good moisturing or not moisturing. So once that you have a good environment for flocking, you have a best result. Once that you don't, you risk to have a not good result. And this is very important for the final result. So I'm sorry, I thought you have been looking at the video I was showing before. But anyway, the electrostatic application of flock needs a blade application adhesive. And then you hear in this slide, the blade is squeegee, that is giving the adhesive, and the electrostatic application. This technology is okay for flat surface, fabric, and films. This is an example of a electrostatic hopper that is used in a flocking lines for fabrics or for films. So this is a layout, and then in this layout you can have what I have mentioned before, the combination of electrostatic, that you have the hoppers, where is contained the flock, and from where there is electrostatic field, and then the flock reaches the support, and the guns, the flocking guns by electro-pneumatic system. This is a combination of the two technologies. After flocking, is very important, the pre-cleaning. I have told you several times, but it's a very important method. Normally, the pre-cleaning is done through nozzles of compressed air, and you need to minimize the compressed air use and maximize the results, or blowers with a calibrated nozzles. This this phase is very important. It allows you to have less excess fiber and allows you to have a better quality at the end. Moreover, you recover the excess fiber and you use in a closed cycle, so your costs are lower if you waste the excess flow. So going to the after the pre-cleaning, we have the drying system. The drying system, okay, there is at room temperature. Can be some big parts cannot enter in any tunnels, or by infrared or by hot air. In this case, the infrared, of course, is very practical, because you don't need a big oven and tunnel, but for some surfaces is okay, but on certain surfaces you have problem of melting and burning the surface. So in this case, you have a hot air dryer. So you have here some picture of a hot air tunnel, an infrared tunnel, air infrared applied on a flat surface product. So we are arrived to the final cleaning. That is very important. You have 3 elements for final cleaning. You have to apply suction system and the blowing system in the same time. So you blow air to get rid of excess fibers, but in the meantime you have to suck to recover it. Or if you have a flat surface, you can use a brush. But in this case, again, you can use a brush. You can apply some blowing air, and in the meantime, you should suck the excess fibers. And the last final cleaning is last but not least, because it gives you the final quality of a product. So once that we are just to show you a bit about what does it mean a flock recycling group. So you have your hopper that is depositing the fiber over your substrate. Then from the hopper you have excess flock going to a cyclone that it can be reused and to put back in the system. Here you have a manual application system where you have spray gun for spraying system, adhesive, the flock system for spraying the flock, an oven tunnel, and the cleaning cabin. So this is what we call a manual system, in a way that you have all the operation need an operator. Of course, this for small scale production can be very good, but once that you need a higher scale, you need to go through a system that foreseen robots. So you have here again, you have in this layout, 2 cabins, one for pre-treatment by flame, for example, one for spraying adhesive with a carousel that the operator puts the part in the carousel and the part is sprayed. And then after the spraying, it goes into a chain. This kind of application, plasma, spraying, and flock, can be unified in a same chain in case you don't need too high masking to have a high masking in the parts. In this case, of course, if you have flame, spraying, flock, pre-cleaning, the dryer that you have here, and the final cleaning, you put in the process a virgin part. You don't touch it anymore up to the time that is completely flock, dried, and pre-cleaned. So this kind of system has big advantages. But of course, in case you need to mask your parts in many parts, is not feasible because the hangers of a chain will be too much complicated. Last, this is a layout instead when you need to flock a fabric or a film. So you have a reel, you have a coating head. I hope that some of you can have seen the video about the coating head. Otherwise, we will show in a second time. Then the coating head, a flocking machine, and a long tunnel oven can be by belt. The transport of a film or a fabric can be by belt or by chain, depends on the system. Then you have a cooling can, the brushing system, and the rewinders. This, of course, is an example. There are different layout in function of a productivity. So you have more flocking modules or less flocking modules or more length of the oven in function of your productivity. Then instead here, we have a technology and line for applying flock in a profile. So the phase are still the same. You have an application of adhesive that can be by brush or by spraying. The flock application by hopper and by gun. So it's a combined system. The pre-cleaning, and then the long tunnel for drying the adhesive. In this case, you use a combination of infrared and hot air. The temperature in this case are pretty high. At the end of the line, there is such a big amount of flock because you are really overfeeding in order to get the density that the flocked profile is merely washed and then dried in order to get rid of excess flock. And so this is a kind of profile flocking system in which the profile has been already extruded but are junked. So there is the profile to have the shape of a door of a car has been junked in three parts. When you make the juncture, you need a new rubber or new plastic in case of PTE. And once that you need new rubber, this part of rubber is not flocked. And so you need to flock the angles. And the corners of the are flocked by this kind of line. It can be manual, but in this case, you have a line that has a belt. You place the parts, and or you have operators or you have robots, as recently has been done with success. So instead of having the operators, you have robots for the plasma application, the adhesive application, and then for the flock application. Then you have infrared system for drying. Of course, you pass through before the important pre-cleaning, then you have the infrared, and then you have a final cleaning. The phase are always the same, but the application system, as you have seen, is very different. So whenever you have to flock, it's really not the same to flock a film, to flock a profile, to flock a profile in extrusion system, to flock a profile in a corner molding system. So I have to tell you that is so wide, the range of possibilities that concentrate everything in a few time is not easy, but at least you have you got a presentation, and I think that I will leave the last 5 minutes for your questions. Oh, sorry, I just mentioned the post-treatment. This is a very, yes.
Alberto, sorry. You have now 5 minutes, then the lecture time is over and we have the break, the lunch break. I don't know how many minutes do you need for your lecture at the moment now?
No, it's okay. The last 30 seconds, because
okay.
I want to tell you about the post-treatment. After that you have flocked your surface, sometimes there is a post-treatment that is can be embossing or print, or some of our members are doing it with very nice results, and it's very interesting technology.
Okay, and after that, maybe you can answer the questions. You can take a look in the chat room. There is the questions.
Okay, so well, I start from the beginning. Oh, for the moment, okay, I have what is the rate limiting process in the line, roll to roll? The rate limiting in the roll to roll line, you have two aspects. There is a flocking chamber that the longer is it, the fastest is the process. But of course, you don't have to think that if I have one module or if I have two modules, I double the speed. If I have one module for some kind of flock, you can reach 5 to 10 meters per minute. If you add another module, you cannot reach 10 to 20. No, because the process of flocking, as you have seen from the presentation, is it cannot be done in one shot. So it has to be done gradually. So if you think to overfeeding so much the flock, you will not obtain a good surface. So the flock has to be deposited gradually. So this is a rate limiting is a flock filled length and the oven length, because once that you have applied the flock, you need to dry, and then you need from 1 to 3 minute drying time depending on the kind of adhesive that you are using. And so you need this time. So the longer you have your oven, the longer, the fastest you can obtain the process. What about flock on flock? this is nice question. This is an interesting question, and this is if you can consider as a post treatment. Flock on flock. You first apply a flock substrate on a fabric. Normally, flock and flock is applied on a fabric, but there are applications in plastic. And my friend Matthias has done it, and I think he won a Flock award on this. So you have first a flock application over the fabric, and then you pass again through the flocking machine for another flock application, but this time you will not use a blade application by a coating blade, a coating head, but you use a screen. So you apply the adhesive by screen. So there is a design. So the design, with the design adhesive, you apply the flock in a design shape, then you dry. Then the result is astonished. You have a 3D result, a very soft surface, and the touch is incredible. But this is not easy application, and is very expensive. So not always the market is rich enough for absorbing this technology, but there are one of our customers that are doing astonish products by this technology. So it's 12, and I don't see more question. If you want to raise your hand, you can have the word. So I thank you very much for the opportunity. I'm very sorry for the problem of the video, because this was a pity. I wanted to show you some video that was much easier to explain you the flock. There is okay, I see thank you, Kristen. And so I would say that thank you again for the attention. And if there are questions, I think there is a section where you can put questions to all of us, so we can answer to your demand and doubts.
Welcome back to the first Flux School in 2021, the last part. I hope everybody has a good lunch. And yeah, we learned a lot about flock, about adhesive, about flocking machines. And now we want to do just a little bit theory about the electrostatic and how it works. And later on, then we want to do flocking. That's why Leo is with me. He's our application engineer for flocking with over 20 years of experience. So I'm happy that Leo will take over that. But let's start with a little bit theory. So first of all, the flock fiber has to be conductive. So we have a flock fiber, which is usually non-conductive, and to make it conductive, we need the preparation. So why do we need this preparation? Therefore, we have a little test here. Yep. So what do we have? This is the flock fiber. Sorry, in this case, it's a round flock fiber. So this will be the flock electrode. Later, I will charge it with a high voltage generator. And this is our working piece. So we would have glue on this. And if we have a non-conductive flock fiber and we charge the electrode, nothing happens. But if we take the same flock fiber, it's also a ball, but with the conductive paint on it. And as you can see, as soon as I'm in the field, the flock fiber will jump back and forth. So why? Because we charge the flock fiber with the flock electrode, which is charged by a high voltage generator, by our mini flock in this case. And then the charged flock fiber will go to the grounded electrode like a magnet. It's an electrostatic magnet. So if it reach the ground electrode, it will discharge and will go back to the flock electrode. And the flock fiber will do this as long as it's in the field and as long as it is not touching the adhesive. Okay, so I think now it's clear. If the flock fiber is not conductive, we have a problem. Okay, I don't have the control of my presentation. So we have now, for the flocking process, we have the working piece, which is grounded usually. And then we have a flock electrode, which is charged with the high voltage. And then we have adhesive on our workpiece. Sometimes it's a conductive, sometimes non-conductive. It depends on if we have a metal plate. It's not so important that the adhesive is conductive, but the whole piece should be grounded. Otherwise, we don't have the field between the flock electrode and the workpiece. And then we have the flock fibers as shown in the sample. If we touch the surface, it looks like, or it feels like all the fibers are really straight. Which is not realistic. That's why we try to show here a picture which is more realistic, but it feels like a straight flock. And this is just possible with the electrostatic, because the field lines go from the electrode to the ground straight. It's always in a 90 degrees angle on the surface. So this is the field lines, and the flock fibers, they will follow the field lines. Okay, but what's happened if we have a bad flock? If we have a bad flock, if we check the two pictures here, this is a bad flock, this is a good flock. So if the flock has angles, we don't get enough flock on the same surface. Now we go to the practice part. Yes, Leo, how can we check the flock, if it's a good flock or it's a bad flock? I mean, it's too late. If it's flocked and it's in dry, we should check it before it is flocked.
Yeah, okay. So the one is the preparation of the flock for the conductivity, and the second one is how are the fibers are from the size and also from the cutting, because if the knife is not really sharp in the cutting process, so we have also bad fibers, a lot of bad fibers, and this only can be make sure that there is no so much trash in while the flock is sieving. But this is a process which takes time and costs. And for the customer who gets the flock, he can test it really easy how the fibers looking, and also he can measure it with a simple machine what is the size of the flock. Or maybe is it a mixed flock between longer and shorter fibers, or the thickness? So it's easy to see this. And for this one, we have the flock shape.
Yep, the new flockoscope.
Yes, flockoscope. And so with the flockoscope, we have a screen. We have a light, which is adjustable. And we have also a scale on it to make the adjustment for the measuring instrument. So, and then we put some fibers on it. So it's a little bit too much, but I think we can really good see it. So here you can see how good is the quality of the flock fibers from the cutting. Do we have a lot of angled fibers? Is there a big difference between the length? So this flock looks really good. And we have also a chance with a special scale to measure the length of the flock. So it's easy for them to check how is the length of the flock. If they're using the scale here, they can measure the fibers.
On the screen.
Yeah, on the screen. Yes,
yeah.
You need to check it on the screen because the fiber is so short and you cannot do it here with the scale. So that's why we have the screen and we make the adjustment before that the size is correct. And then we can measure on the screen really easy with the scale how long the fibers are.
Yeah. Can I store the picture?
Yes.
For quality sake?
Yes, we have a SD card in, and for the quality, it's really easy. If they take a picture, they can store the pictures for any other processes later. So maybe for the and the mobile industry is really interesting.
And as you maybe recognized, we put the screen on your presentation, so you could see the screen of the floccoscope because it has a HDMI output, and with this HDMI output, you can also take a bigger screen if this one is too small for you.
For a presentation.
Okay. Good.
Okay.
So now we have something we heard before. So we have the flock fiber, we have the wet adhesive, and then later it's the dry adhesive. And you told me 10% of the flock fiber has to stick into the glue, and I think we learned this morning already. So why is it right? Is it 1/3?
It's
1/10?
It's 1/10 in the dry condition of the glue. This is important, not the wet condition, and it is different from the systems of the glue. Sometimes we have a water-based glue, which normally has 50% of water inside, which is drying in the process. So it reduces the size to the half. So if a 1 millimeter fiber we have, and using a water-based glue, we normally apply 200 microns.
Okay.
And the 200 microns for the water-based, and with the solvent one, it's lesser. It's around 130 to 150 microns. Depends from the systems of the glue.
And what's happening if it's not 1/10 in the glue? It's maybe just just 5% or 3% in the glue?
Yeah, okay. For first, normally it's not a problem for seeded part is flocked. If the layer is too less, you cannot get a good result of the flocking because the fibers will not stick in the glue and will not hold. Maybe they will be taken out from the energy of the applicator or from the generator and will go back to the screen. So this makes some problems because the flock fibers which are sticked in the glue go back to the screen and we get a big mess, on the screen. And for the result for the customer, especially the automobile industry, is important because they had to do some tests later. So there are different tests. There's maybe one test which is a tear test, where they try to take out the fibers. How many energy do you need? How good they are fixed in the glue, and also the glue on the substrate. And there's another one which is really famous, is the aberration test. So this is simulating a test like a fingernail. Each customer or each automobile has a own specification. So they give exactly the informations to the customers after doing the test. And if you have a bad layer, you can easily scratch them out. And so after some years, you have no fibers on your part. So this is important to have a good layer that the fibers could stick in the glue.
Okay, good. So now we see a picture of a manual flocking. So very important that we have the grounding.
Yes.
And from electrostatic point of view, it's very important that we have the generator going directly to the ground of the working piece. So not somewhere over the ground of the power system, better directly. We need a direct connection between the working piece or the glue. If it's a non-conductive working piece, we have to ground the glue back to the generator. In our case, it was this ground wire here directly connected.
Okay.
So if we look at the picture, then we have a flock table. Do we really need the suction, or is it, what is the pros and cons about the suction?
So if you have only a small production or maybe make some samples, it's possible to do it without a suction. But the problem is if you have any airflow in the room, the flock fibers are so small. We learned it from Velutex that what is the size of the fibers, and so they flow anywhere. So it's much better for a process to have a flocking table or a flocking booth which has a vacuum unit who sucks the flock. Yeah, and you can also reuse the flock. This is important.
Yeah, I remember when I did the first flocking tests in my younger years. I think I had almost the same amount of flock in my face and everywhere and on the piece because I don't have any suction. Okay, so in a manual flocking unit, I don't think we don't have to tell too much about it. Alberto told everything about machines.
Yeah.
But we have the dosing system, and here the only thing I want to mention is that we have a direct connection between the high voltage generator and the ground of the system. Yeah.
So in this case, we have a belt which is moving and transporting the substrate, foil or textile or anything else.
And then the last application is the electrostatic pneumatic flocking, where we have the flock dosed by a blower, or supported by a blower, and we have the electrode in the front. But if I'm right, you will tell us a little bit later about practice with the electrostatic pneumatic. And we always say we like to flock it, so let's flock.
Let's do.
Okay, first of all, we need a ground plate.
Yeah.
So I will install the ground plate, and then we connect.
I prepare the glue.
The ground wire. And of course, we need any kind of flocking system. Okay, Leo, just prepare the glue. We'll be back in a second.
So we also
I think I go out of the picture. It's your.
We also need to prepare the generator and the applicator with the flock. The flock fiber is here. So, okay, we have a paper sheet. This is really easy to show you how it works. We have the grounding going to the metal plate. We have a metal plate because the paper has no conductive. It's much better to have a metal plate on the bottom. So I fill in the flock. We have different sizes of the applicators in our Mini Flocker Pro. We have a 180 millimeter size, and we have the 120, and we have 3 different sizes of the screens. So because it's different, if you have a short flock or you have a really long flock fiber, you need to use the correct screen, because if too much flock is coming out at the first step, it's not good for the result, because the fibers will not going straight in the glue. They're laying a little bit down, and the result and the feeling of the flock result is not so good. So it's also important to make a good glue layer. Normally the glue is depends from the parts is applied by rolling, brushing, screen printing, but the most in the automobile industry is spraying. So in this case here, we have no spray booth. I need to roll it. Okay, I bring a little bit glue on the paper. And it's important to make a correct size. If the glue is too less, it doesn't work. So in this case, I watched the application and I think it's a good layer, but there is also a chance, we heard from Kivo, that it's easy to check the layer of the glue with a special equipment. It's only touching in and then you can see easy what is the glue layer. Because for the 0.5 millimeter flock, we need a much lesser glue layer. Okay, and now we have the glue. We have a solvent-based glue. There is no problem with the time. If it's a water-based, we need a little bit to be in a hurry. And I'm flocking now. Okay, starting the flock process, not directly on the part. We started always next to the part so that we are making sure that no fiber which are not good charged going to the part. So, okay, you see, it's really fast. We are finished. So the flock is only sticking in this area where the glue is. I can remove the flock, which is exactly on the corners. I brought my glue on, and it looks really nice. And the next is, people must take care that they do not touch the wet flocked part. So now it needs to be going in a dryer system. Different systems are available. And after the drying process, there is another thing which is really important. A lot of people touching the hot parts coming from the oven, and they press down the flock in the hot glue. So it's really important to give the time for the parts to cool down to room temperature, and then they can handle it. So normally after the good drying process and cool down, you can clean them, pack them, but only for the final resist test, they need to wait the time.
I think,
recommend.
yeah, I think I like to redo it one more time. And so how important is the distance? You know, can I have a big distance or a lower distance? So how important is that to the flocking result?
The distance depends from what kind of equipment do you use. If you have a really big roll-to-roll system, the distance can much be higher. So maybe 40 centimeter or 30, it's not a problem. But a lot of people doing a mistake and starting the process too close to the part. So normally it's much better to using the flock system and we start the process a little bit more distance. And after this, if there is a good covering anywhere, then you can go closer and bring more fibers in.
So if you get closer, the field will be stronger, and then you can fill
more fibers between the others. So
okay. Well, let's do it again.
Okay.
And maybe we focus on exactly the distance.
Okay. So this is a flat part, and here it is really easy because we have no concentration of the electrostatic field. It's more complicated if you have a hand glove box and you want to flock it outside and also in the deep areas inside. And here it is much more complicated to having a good flocking quality and that it looks nice anywhere, because otherwise if you start to close to the part, the direct areas which are on the top are looking really black because the fibers are straight, and on the bottom we have a problem that the fibers not so straight, and then we have shadows in one part, which is not nice, and the people do not like this. So this is important to start the process, especially in the automobile industry or with a pneumatic flocking, a bigger distance, covering a little bit with flock, and then going closer to the part and fill it up. Okay, you see the areas. And now we do it again. You can also see that the fibers needs time to fill up. It's not done in the first step. And now I can go closer.
Mm-hmm. I think you've done this before.
Yeah. Not only once time.
Okay, so what kind of device you're using and what is the usage with this device?
So the device is the Mini Flocker Pro, which is a brand new machine and has a good power. We have more than 60 kV of high voltage. We have different applicators. We have 3 sizes of screens. And we have also a conductive plate, which is inside. It's easy to clean from the flock. If you have any electrodes, metals or anything inside, it's not so easy to clean. In our case, it's much easier. And really good is we have a battery. So we have a rechargeable battery, which what is a Li-ion battery, 5000 milliampere. And you can, with a power series, you can having a long working time with one battery. The machine is delivered with one battery, and we have a charger which is included, and we have normally you can have a second battery, and then you have a time for a long time to work.
Yeah, behind the camera there's Mario. He's the developer of this unit. Mario, so what do you expect? How many hours can you flock with one charged battery?
4 to 5 hours.
So
Yeah,
4 to 5 hours with one battery. And so if you like to flock more, then it's good to have 2 batteries, so you can. But this is the Mini Flocker Pro, and as I know, what I know, this is for prototyping and doing samples.
Productions, yes. So if we have a full production for the for longer processes, we have another machine. Which
then you
is
need a bigger one, isn't it?
Yes. Yeah. So we have the Easy Flock, which is connected to the power by a cable. We have 85 to 265 volt input, and we have 80,000 volt coming out here. We can adjust the current, and also, can you hold this? So we have the handle with a trigger. We can also use a foot switch or anything else to start the machine from other signals. And we have the same sizes of applicators can be fixed here on the cable. And now we have a machine which can work the whole day. Good. So this is for mass production, gift cards, so a lot of people using this system doing flock jobs by hand.
Makes sense. Okay.
Okay.
So now we have just take the applicator here.
I take it out. Okay.
Get this out of the way, and then so there was all the time it was a flat surface. So,
yes, it was a flat surface.
But how would we have a sample like this? So by the way, this is a 3D printed housing of a speaker. So 2 shells will be a speaker system later. So if I want to have this flocked, how can I do this? Can I do it also with the applicator like this?
It is possible, but not in a good result, because you see we have outside areas which is here around, and this would be possible with the electrostatic flocking unit to doing the job. But we have a really big problem going in the edges. Okay, and the deep areas, hand glove box is also really deep. And
it's a Faraday cage.
It's a Faraday cage, yes, that's it. And so this is blocking the flock fibers to going in, and that's why we have to using a different style of machine. And this is the air flocking pro machine. So we have a system here which has a container. We can put in 10 kilograms of flock, and we have adjustable parameters here. We have also 80 kV power, adjustable current. We have a handgun which has different styles of electrodes. In this case, we have a standard electrode and for the electrodic ball, which is charging the flock fibers here. And different is it that the flock will come from the machine when I'm pressing the trigger with the airflow to the gun, and then I can easy flock the part. In this case, it's important, you have no chance to make rolling the glue here. It's important to make the glue spraying. And in the automobile industry, the water-based glue is really famous. And there is one thing you need to know, that the time between the application we learned and the flocking process should not be too high, because otherwise the fibers will not stick in the glue or maybe stick deep enough in the glue for the result. And this part will be flocked with this machine. We have also presets. This is what we can do here, because a lot of people have different parts and always they're doing this part and this part and this part. And normally they should not only always make the adjustment of the machine.
So they can store parameters
in the machine and only selected, yes. So it's really easy for the process and makes it much safer.
But I think we should not run the unit live.
No, here we cannot run the machine here. This is one thing, because if you're using with the airflow system, we have coming air out of the nozzle transporting the flock, and we have the flock all over the room here. So this is what we need to have, a flocking cabin which is closed and having a suction.
Yeah, I don't know if we saw that on the video. It just bumps on the plate.
Yeah, this is also new, because normally you need a holder, otherwise the people throw the gun in the cabin and will produce some problems and damages. And there is also one thing, because if this one has the electricity of the nozzle, it's always discharging. It's not good for the cascade system. So that's why we have a magnet here. And normally the flocking cabins are produced from metal. So you easily can take it and just take it on the wall inside of the cabin, anywhere else.
And can you just show us how you would flock a sample like this without flock now?
Yeah, okay.
Right? Just
okay,
to give us the
principle,
principle, you know, how
okay.
do you handle that?
Spraying the glue, and then first is not starting the flocking process when you're in the direction of the part, because the first fibers which are coming out maybe has a big airflow, because the machine always makes sure that the air hose is cleaned and we have a constant flock flowing, and not too much flock is coming in one step, because when too much flock is coming from the hose and going in the part, it's not charged good and we have a bad result here. The flock fibers only laying in the glue and not straight. And that's why it's important to having the part. You start the gun here, waiting for the process. We have an adjustable time for the cleaning process of the machine. It's really easy. You can do it in the parameters. And so maybe 1 second or 1.5 or 2 seconds, with what is normally for the process. Only just wait here and then going to the part. And this is important. If you're going close like this, you will have a lot of black areas here which are dark because of the direction of the flock fibers. And here we have light areas, and this is not good. So important is to flocking with a bigger distance beginning the process, covering the part all over. And then if you have a good coverage of flock fibers here, going closer, and then you can prepare especially the edges, the corners, and
but usually this is on a hanging system, isn't it? Inside a flocking.
You can use a hanging system. You can also hold it by hand. Important is a lot of people are only taking the parts on a blade and do flocking from the top to the bottom. And the problem is that the flock fibers, which are not fixed in the glue, will lay here in the areas. And this is a problem that the next fibers which are coming cannot move to the glue. And we will not get a really good result of the flocking in this case. So it's much better to having holder or anything upside down. Okay. So because the charged fibers will stick in the glue, these fibers which are not fixed in the glue automatically drop down, can reused again in the machine then. And so we can make a good coverage of the flock fibers. So the regulation normally say we have a coverage of flock which is around 10% of the size. A lot of people think it's much more, but it isn't.
Okay,
Depends from the fiber length.
so let's get back to the flock applicators. If we have a flat surface, or
Yes.
we do some test papers or something. You mentioned we have different screens, yeah, with different sizes. I think we have one here. Let me just double check.
Yes, we have 3 sizes of screens.
So how do I know which screen should I use?
Yeah, normally the people always ask, can you explain me what size of screen is the best one for my flock and for my application? So we can only give informations what should be started. And this is normally a 1 millimeter flock here, which is the most used flock in the industry, the 3.3 DTEX 1 millimeter, or maybe 0.75. And I used the middle size of the screen because otherwise you can also use this fine screen, but it takes a little bit longer. It depends also from your parts, what you do. If you have only just gift cards, which are a small sign, which is the glue was applied by screen printing, you can use the smaller one. Everybody must find the correct adjustment for his production, okay?
Okay.
But never use the bigger screen if it's not needed, because
Okay.
if I use the really big one, too much fibers coming in the first step, and the result is not like good like in the middle one or the fine screen. Okay,
Yeah.
but it makes no sense to use the fine screen, and takes too much time for the flocking.
And by the way, the screens are produced in-house at SCHNIER, so we can also do customized
Yes.
dimensions. So
Yes.
if we don't have the screen you need for your application, we can do
Yes, we can do a
special
size
one
of screens
for
and
you.
also maybe special areas. If anybody wants to have only small area flocked, and they say, okay, too much flock is coming out in a big area like this, I do not need, I just only want a small area. So we can especially make a screen which has only just a smaller area in the middle, which the screen is open and the rest is closed. But we have one thing, that we have a big container. The people normally, if they use a small applicator, they had to refill flock again and again and again. And this is not really good for having a continuous process. And here we have the chance to having a bigger applicator, more flock in, and just only a small application area.
Okay, good.
So that's
And I saw you shaking.
a little bit, yes. It depends from the flock.
It depends on the
It
flock.
depends from the flock. Sometimes the colors are different. So we cannot say we have a 3.3 DTEX 1 millimeter, which is red or white or blue or black, because the black is normally spun dyed. Other colors has the colored in the special process. And it depends a little bit from the fiber. It depends from the humidity, which is in the room. This is really important. A lot of people are working especially in the winter time when the humidity is really less. We have a problem that the area has to dry. Flock fibers will dry really fast because we have not a big quantity of flock, or big, the size of the flock. So this flock is drying really fast and loosen the humidity, and with the humidity they also lose the conductivity, and then it's not working really good in the process. In a flat area like this, it doesn't matter so much, or in t-shirts, it's not so important. But if you want to do three-dimensional parts like this, it's important to control the humidity and the temperature in the rooms.
Okay, I think last question from my side. So we saw the floccoscope where we can check the flock fibers, how they are, if they are the same length, if they have the same color, if we have color mix in the flock, which would be really bad, I think.
Yeah, sometimes people using different colors in the flock, maybe black, to identify their parts later. Or maybe sometimes it's good to mixing flock. You have a 1 millimeter flock, and you have sometimes if people have an angle 90 degrees, a sharp corner, no round. Yeah, because this is helping for the process. Sometimes we have parts like this, and it's not good with a 1 millimeter flock to fill up exactly the corner. So then it helps much more to make a mixture of the glue fibers. So if you have a 70% maybe of the 1 millimeter and only 30% of 0.5, it will help the customer much to make the parts much better and easier and faster.
Okay.
But this is always important to clear up the situation with the customer.
But what would you, if somebody starts professional flocking, what would you recommend as test equipment? So the flock inspect, it's good for quality saving to check the flock before you flock.
Yes.
I heard about conductivity meter. That's something I hear if I'm talking to a flocking company, they always said that's the important measuring device, that you can measure how how is the conductivity of the flock. Is that something you would also recommend?
Yeah, normally the flock is controlled by the suppliers before they ship it out, and we have normally in the area a really good flock quality. Also, the glue is controlled by the suppliers, but it's also good for a customer to have the equipment in-house to doing any tests, especially for documentation, and maybe if there is a problem with anything, they had the chance to check it.
So you would recommend a floccoscope, which is quite inexpensive,
yes,
and maybe
conductivity of
conductivity. So right now, that's just in future. We're working on a inexpensive meter to measure the conductivity of flock. Maybe. Yeah, if we are fast, I have to look to Mario behind the camera.
I think we maybe do a lot of things,
in another 6 months.
Yes, okay.
We can have an inexpensive measuring device for conductivity. Okay, so I don't know if we have any questions. There are questions. Okay, then.
So thank you for this great lecture with a lot of action. It was very nice.
With a lot of flock here.
So at the moment we have two questions. The first question is, how does the fiber length affect the electrostatic flocking process?
How does the fiber length?
I would not say that the fiber length is such a different. I mean, if you have a short fiber, I think that's maybe what it is. A short fiber can be, I think it's more easy to get it straight, and a long fiber maybe needs more energy to get it straight.
Yeah, and I know what they want to know, because if you have shorter fibers, so the fibers are closer together. So each fiber is creating an electrostatic field around after sticking in the glue. So if you have a big fiber, so maybe a bad quality of flock which has a lot of longer fibers between, we get some sparks. It looks, especially in the flat area of the flocking, you will see it looks like holes, because one fiber is creating, especially in the beginning of the flocking process, going in the middle, creates a field around, and the next fibers which are coming are not able to stick next to this one. These fibers are following the field around this fiber, and this makes, in German we say Krater. I don't know the word in English, but it looks like points, or yes.
Orange field.
Orange field, yeah.
This is affecting the length of the fiber, how longer the fiber is, how more distance you have between the fibers, and how shorter the fiber is, more fibers can going in the same area.
So if it's a really long flock, then it's maybe better to flock with a little bit less high voltage at the beginning, or a higher distance.
Yeah, exactly this, because a lot of people think if the result is not good, especially also in the three-dimensional parts, the quality is not good, I take it higher. It's completely the wrong way.
Sometimes less is more.
Yes, yes, that's it. Because the electrostatic field makes problems with the fibers, because if I have more energy coming from here, the field is stronger, and the fiber has no chance to go in exactly here. If I have a Faraday case here, and I push up the high voltage, I will create this problem much more than lesser. So in this case, it's better to reduce the high voltage. It maybe reduce a little bit the speed of the airflow, because this is always important. if you have a box and you blow in some air, the air also should come out. If you have corners, the airflow is not going this way in the corner and coming out. It's making a cycling inside. And to fill up the corners, it's much better to reduce the parameters and not to put them higher.
Good.
Okay, so the next question, are these all DC machines or AC?
Yes, DC machines. I just knew a few AC machines I saw one in the US. AC machines are really dangerous.
Yes.
I'm not afraid to touch an electrode here with the DC, but I'm really afraid to touch an electrode with AC.
Yes.
I think with the AC, it might be possible to flog non-conductive flog, maybe, I don't know. But I don't know a lot of, do you know AC machines at all?
I saw some in other countries. Here in Europe, it's normally not standard, but I saw some of them, but just only visiting like this, because it's so dangerous. I saw really big sparks, and a lot of people has problems, get a shock from the machine, and okay, this is not standard.
Klaus is still in the room. Klaus, you'll be all over the world. Do you know a lot of AC machines?
Well, I don't think so.
Okay. He said he don't think so. I don't know if you can hear him. But yeah, that's my experience as well. And it seems we three have the same experience.
Yes,
okay, next question.
Okay, we have another question. What are the health concerns with flog dust? Is this worse or different fibers types, egg-glass fibers or milled fibers?
So normally there is not a problem with the fibers if you take them inside, because the fibers will not leave in your body. You can, what is the name of this?
Cuff.
I don't know.
Cuff to cuff.
Cuff them out, yes.
I just know the German word. It's not all alveolengängig.
Lungengängig in German we say yes.
It doesn't go in the lungs, in the end of the lungs.
Yeah.
But I wouldn't breathe too much of the flog.
Yeah, I recommend for the people who works the whole day in the flocking, they're using standard masks. They only have a dust mask is completely enough. And because it's not always good to flocking today red, tomorrow blue, and then green. So every day you have a new color in the nose. And I think it's better for the people who are working in a constant process to using the masks when they are flocking. So it's much better for them. And also keep sure that they have clothes they can easily remove the flock.
Okay. Is there any question else? Then I give it back to you.
Okay, so I gave every speaker a micro. So if you have some questions, please write the question in the chat and the speaker can answer it. One moment, please.
I think there was one question missed. There was one question regarding if there will be changes if the adhesive layer is, for example, 20% instead of 10% or 1/10, for example, when it's 20%. So it's more or less, so we say that 1/10 is like the standard value, but you need to keep in mind if you put on more adhesive, this leads to that the fiber is stuck more and more into the adhesive. This furthermore leads to, sorry, I forgot my video. This leads to that the requirement or the value and advantages of the fiber, which is that it can be moving, it's water resistant and its other resistance, can be affected by this. Also, when it's too much in the adhesive layer, it feels different. It has it doesn't have its requirement it normally has. So we require also to stick to the 1/10. This is you can also drown a total flock fiber, so you can fully put it in to the adhesive layer, but this does not help So yeah, we say it's better to stick to the 1/10. If it's a bit more, it's not that bad, but yeah.
Well, going to the AC Flock, we have had a huge experience about these kind of lines supplied many years ago in United States. The main differences between AC and DC are that the fibers fall down from the hopper, making this movement up and down, up and down, up and down, because the positive and negative continuously change the position. And these characteristics allows to flock at high speed, because you reduce a lot the problem of craters and the defects on the surface. In the same time, the density, the flock density in AC is less in comparison of DC, of about 20%, sometimes more. So the AC flock is good to employ for working at high speed, mainly for lines working fabrics or film, and however lines working in a roll to roll. It is also true what mentioned before by Schneider, that AC is extremely dangerous for fire and operator safety, because the milliampere are highest in comparison with DC. And then the flock fibers must be activated for being sensible to the AC lines. So flock must be duly produced according to the technology employed. And then also the huge level of milliamperes in comparison in AC in comparison with DC increase the risk of fire in case of sparks and increase the risk for operator safety. In fact, for AC lines, it is necessary to employ a special ways for operator protections and safety sensors and devices.
What is a typical weight for the flock surface, and what would be a minimum weight per square meter flock and adhesive? Who can answer that?
Well, I don't know if I can answer, but this is a question that is a transversal for glue, flock, and machines manufacturers. However, the wet thickness on the surface for allowing a good flocking is around 0.1 up to 0.2 millimeters wet. And then flock change the weight according to the length. So giving a number for a minimum weight per square meter is not easy, because you can reduce, of course, the thickness of glue, but then you risk to lose in terms of abrasion resistance. However, the figures are relatively easy to calculate, because we consider about 100 grams per square meter of flock, but then that depends about 100 grams per square meter of wet glue. And but you have to consider these figures like an estimation.
Yeah, so it's Andrea, exactly. It's roughly like you said. So when we go on a 1 millimeter length fiber, we, as mentioned, we say around 200 grams per square meter. And it's hard to say, but it's at least the same quantity of flock. So when we have 200 grams adhesive, it's at least 200 grams of flock fiber. I think we have calculated, Jürgen, once. Maybe it's also more. It's yeah, let's say 400 grams in total per square meter. Yeah, Jürgen. Yeah.
Okay. And there's another question, maybe Klaus can answer that. And the question was, is flock powder sold by kilogram? Or is a fine milled flock powder more expensive than a 1 millimeter fiber?
Normally, the 1 millimeter fiber can either be viscose fiber or polyamide. At the moment, polyamide is much more expensive and increasing day by day than the viscose fiber. But the molded fiber, it comes from pulp, and viscose pulp is cheaper than the tow than the viscose. So normally, a viscose grinded flock will be less expensive than a cut viscose flock, and this will be less expensive than a polyamide flock.
Okay. So there's
about there is a question about post-treatment. Perhaps if I can give some comments.
Yeah, but just was one question before. Let's go question by question. So there's can anti-static air gun be used for cleaning excess flock for the cleaning of surface? So
yes, sorry, I lost this question. Yes, we employ some special guns for helping the cleaning of excess of flock using gun working with ozone air that are reliable and effective.
okay, and then the next question was what post treatment should be done?
Well,
to discover the flock surface to
in our experience, we have in this specific field we have experience in the field of flocked fabrics, because there are some products coming from companies like DuPont that can be coated through a special lacquering roll on the surface of flock in order to help to clean the surface. This is a kind of finishing employed not only in flock, but also on the fabrics used for sofa, canapé, and pillows, chairs that you have at home, for helping to clean the fabrics easily. And this is a way for helping to clean the surface, flocked and not flocked. We do not have experience on this, or at least we do not have a technique known for three-dimensional surfaces.
Okay, so we have Steve Rosenthal. I have suggestion about the weight of flock. Let's try to unmute you. Can you? Yeah.
Okay. Basically, if you're doing roll-to-roll goods, there is a technique to measure the quantity of adhesive and the quantity of flock you put down. Once you have a good piece of goods coming through the other end of the machine, you take a piece of paper. It can be a paper towel, and you need 3 of them. And I'll see if this diagram, it's not going to work. But what you do is you put down on the bare fabric, you know what the bare fabric weighs per unit, and you take a piece of metal that you can dink out a small circle. You know the weight of the fabric. Then you put a piece of paper down so that no flock, after the adhesive goes on, so no flock goes on it. When it comes out the other end of the machine, you also use that same piece of die cutting equipment, measure its weight. The differential is the amount of adhesive per square unit. And then finally, you take a piece of totally flock goods, use that same die cut unit, cut the same size piece of fabric, weigh it. That tells you how much flock you've added on. So now you know your flock weight, your adhesive weight, and this is your standard because you now know that this is a quality piece of product. You can repeat that over and over.
Okay, thank you. And Patrick asked, is anyone producing microfiber flock?
Hello? Yes, we are producing microfiber flock. I mentioned this morning, maybe it was not clear. We are producing a microfiber flock of polyester, which has a detex of 0.3 millimeters. That means 0.3 grams per per 10,000 meters, you know, for one file only, for one, how you call it, Elo? For one fiber, you know. And we are producing this polyester flock 0.3 detex in 0.3 millimeter length. So that's a microfiber which afterwards can easily be printed and is often being used in the packaging, luxury packaging industry, where you need a printing afterwards, because polyester is easily to be printed, much better than, for example, a polyamide. But it's extremely expensive because the whole process is expensive and it's very delicate to flock. Leo would say, don't take too much kilovolts, otherwise the flock will be everywhere. Okay.
Okay, then there was another question from Mahmoud. Do you have any experience on the flocking of fibers which are highly conductive, such as carbon or silver flock fibers? What kind of adjustment should be done on the equipment for using those conductive fibers? So who will be able to answer that?
Well, we have had experience in the flocking glitters that what we do, we manufacture some scattering devices that are not exactly flocking machine, but equipment that allows to spray fibers. When these fibers, carbon, silver, or other materials, are sensible to the electrostatic field, we employ the same technology or similar technologies employed in flock. But the final result is just to help to the fibers to be more uniformly distributed on the surface. Up to now, we never succeeded to have these fibers standing up, because this is a matter that involving mainly the producers of flock fibers.
Okay, then Pedro, is that how to prevent bubble in flock?
Well, I can answer for what is concerning the equipment. Normally, we always suggest to keep the flocking area into an air conditioning room in order to keep always stable temperature and relative humidity. So temperature is around 22, 23 degrees centigrade, and the humidity around 50, 60%. And then some equipment are equipped with special devices that collect bubbles of flock during the process. The rest of the job is done by companies manufacturing flock that manufacture flock for limiting as much as possible the bubbles. And Klaus perhaps can answer about this.
Well, Andrea, I don't know what they mean with bubbles. I think he's
small stones of flock, agglomerates.
Agglomerations of flock, you mean maybe, which then get into big flocking machines, in continuous flocking machines. The flock, if you have, for example, a 22 detex in 2 millimeters, you can get balls, nice snowballs. If the flock is too wet, or if the humidity outside of the machine is too wet and the flock takes all the humidity and then gets, after a while, it gets after the brushing, and in the hopper, it gets then nice balls. So this you can avoid if the flock is well prepared, not too wet, and the outside temperature and also the outside humidity is not too high. Well, we had this with some companies and they showed us the snowballs, and we had to adjust the machine afterwards, you know. So you can avoid this by the good preparation afterwards in the working conditions with the machine.
Okay, and we have an answer from Steve.
Yeah, if he means, and this could be a translation issue, if he means blistering after coming out the other end of the machine, the solution to that is, as someone mentioned earlier, with water-based adhesives, you get a quick skinning over of the top. And so you have to dry the moisture out before you start curing. And if you hit it too hard, if you put too much heat on too early, you'll skin the top of the water-based adhesive. Now you have steam being generated where moisture trying to get out, it fights through that surface, and that gives you a blister. So if what you're asking about is that's the solution, is to lower the temperature at the front end of your oven and slowly bring it up with a water base to about 320 Fahrenheit, and that will cause the curing. Curing will take place very quickly once you've driven all the moisture out of your adhesive.
Okay, thanks, Steve, for this answer. And then is another question from Pedro. Is it possible to increase conductivity in used flock? I can imagine that this will be an interesting question, because what if the used flock is not conductivity is not high enough? Klaus, can you answer, or Leo?
Yes, it depends. What is the effect of the reducing the conductivity? Is it only losing the humidity in the flock, or is it just removing the preparation on the flock fibers? If you have the second one, that you lose the conductivity outside on the fiber, you can only prepare the flock again with conductivity, but this is only possible by the suppliers. And if it's only dried, you can bring the flock in an area which you have controlled humidity. Sometimes we have people, they have no areas which has a controlled humidity. The flock dries really fast, and the fibers did not work really good in the field. So if they have the chance to bring back the fibers in the area which has around 50–60% of humidity, and leave there the fibers for maybe some hours or days, they will get the humidity back and will work much better than again. But if it's the preparation damaged, it's not possible for the users to repair the flock. So they only can get in touch with the suppliers if they can do anything on the fibers again. I heard it that sometimes they did it.
There was Andreas. Andreas Fröder, you had the hand. I don't know if you wanted to say something. You can unmute. Okay.
Can you hear me? Yes.
Yes.
No, I just heard that Leo was explaining very well the question about increasing the conductivity. As he said, it's really important to know if it's really a damaged preparation. This can happen by mechanical treatment in the process, let's say in the conveyor system or somewhere else, but also due to a lot of electrostatic reuse. If you reuse the flock often, then it loses the preparation, then the humidifying will not help enough. So in this case, it could be possible to recycle the flock, but to be honest, in the last years, this is only economical sensible if the quantities are really very big, because due to the transport back and forth, and it's normally it's not really economical. But Leo explained perfectly, so that's why I hold down my hand again.
Okay, thank you, Andreas. I don't know, Klaus, you want something else, or is everything answered from your side as well?
No, I think it's answered from my side. Of course, the flock gets different treatment in different machines. As long as you have flock only treated by electronically application, the flock is not so much used. But if you have big flocking cabins where millions of fibers are turning around with the flocking system of air and electronically, due to the friction, of course, the flock loses a lot of treatment, so you can't reuse it very often. And if you reuse it often, you have to mix it with fresh flock, otherwise you won't have any good results.
Okay, so any question or so? Okay, there's another question. How European countries and developed nations disposed used and not working flock? So how European countries and developed nations disposed used and not working flock?
Well, from our side of view, we are taking often flock back from customers, which the flock when the flock doesn't work anymore, and we recycle the flock. It's one way to save resources, because actually, as I told before, the prices of the polyamide is increasing. So if we get the polyamide back from the customers, we reuse the flock, we wash, as we can say, we wash the old treatment and put a new treatment on there, and then you have a perfect flock. And we also can do it with colored flock. We are taking it back, and then we can color it in black, and it goes back to the customer. It should go back to the same customer, but because we don't sell the flock, the recycled flock, to other customers because of the warranty and all this stuff. Okay.
Okay, any question else?
还是没有直接回答这个，这是在用，这最后不能用了怎么办？可以，其实这个。
Okay, so I think we come to the end for our first online Flux school. I want to say thank you to every speakers and participants, and a special thank you to SCHNIER, our member, with this great location and the great setup for the Flux school. Thank you so much for your support. We will see, maybe we have some online webinar this year again in the winter. I don't know, we will see. We keep you up to date at our website and our Flux news, and also about the symposium planned next year. So if you have another questions, tomorrow you get the email addresses from the speakers, and you can send directly your questions to the speakers. And so thank you for your attention, and have a nice day.